Melang, I will be doing question 3. It's a continuation of question 2 of the May 2023 exam. Now, A requires us to simplify without using a calculator. When I looked at what I was given there, I noticed immediately that that is the expanded form of our compound angle sine. And what I did is that after identifying that this is a compound angle and it's the expanded form, I just had to reduce that extended form using sin, which is, because it's the expanded form of the sin compound angle. Now, how do I reduce it? You will write it as sin of 85 degrees plus theta minus 25 degrees plus theta. That's how you will reduce that expanded form. Now, inside the bigger bracket there, you've got negative in between. The second bracket, to break it, you will just multiply by negative. You will end up having negative 25 degrees minus theta. And you will subtract 25 from 85. You'll minus theta from the theta. Theta minus theta is 0. However, 85 degrees minus 25 degrees, that will give you 60. And sin of 60 will be the square root of 3 over 2. Done. Let's move to the second one. With B, we need to simplify that 10 negative theta times sin of 90 degrees plus theta plus sin of 2 theta divided by 2 cos 360 degrees plus theta. Now, that requires me to know my reduction formula. I'm not good with memory. I did specify that my memory is not that good. And I will tell you why I had to find other ways of making sure that I understand what was going on. When it comes to reduction formula, what I realize is that I have a Cartesian plane which starts at 0. And as I move anti-clockwise, my angles become positive. And as I move clockwise, they become negative. From 0, if I move anti-clockwise by 90, I'll get 90. From 90, if I move anti-clockwise by another 90, I'll get 180. And from 180, if I move anti-clockwise by 90, I will get 270. From 270, if I move anti-clockwise by 90, I will get 360, which we refer to as the revolution. So as long as I'm moving anti-clockwise, my angles, I'm simply adding. That's what I'm doing. When I move clockwise, I'm subtracting. That's what I identified. Now let's look at that 10 of negative theta. The fact that we've got 10 negative theta, it means it's 0 minus theta. It tells you that the angle we are at is 0, but from 0, when you minus it's clockwise, we're moving clockwise from 0. And that puts us in the 4th quadrant. And in the 4th quadrant, the only angle that is positive there is cosine. Since 10 is negative in the 4th quadrant, we'll end up having negative 10 theta. Let's go to sin. For sin, which is sine in this case, we're moving from 90. When we plus, it's anti-clockwise, and that leaves us in the 2nd quadrant. However, sine in the 2nd quadrant is positive. So I don't need to put a negative there. It's just positive. Now, once you've allocated the sign, you can change the ratio. Please remember this. Do not change the ratio before allocating the sign. Okay, like I've told you here, sin in the 2nd quadrant, it's positive. That's why I will not change the sign. It is positive. However, if it was negative, I was going to put the negative and then change the ratio, which is the sin. When you change ratio, sin is going to give you cos. The reason why in my Cartesian plane I highlighted 90 and 270 with red is because those two ratios, those two angles, they change the ratio. So if it was sine, it'll change to cosine. If it was cosine, it'll change to sine. If it's tan, it'll change to cot, and you know the rest, right? Now, because that one already is positive, I'll just change the ratio. So sin will change to cos. That's why we'll end up having sin of theta. The double angle in the numerator, really, that is just for us to expand. I'll go to the denominator where I have 2, cos there it's 360. 360 is where 0 is. I'm moving when I add to it. I'm moving anti-clockwise, and anti-clockwise, that'll put me in the first quadrant where all the ratios are positive. So cos in the first quadrant will be positive. That's why in the denominator of the double angle sine 2 theta, I'll have positive 2 cos theta. Now, in the next step, you'll just have to use your identities to change 10. 10 will become sine theta all over cos theta, sin theta all over cos theta, and double angle sine or sin 2 theta will be 2 sin theta times cos theta. Now, you know these rules of multiplication whenever you multiply fractions, all right? Note that that cos theta that we have multiplied with negative sine theta over cos theta, you'll just multiply, it will be in the numerator, and that is because we cannot just multiply any number with a fraction. That number has to change into a fraction as well. So you end up multiplying the numerator with numerator, denominator with denominator. I won't go there. By now you should be understanding that. But you'll notice that cos there is in the numerator. And once you have the same base with the same exponent, and the one base is in the numerator and the other base is in the denominator, but they have the same base and the exponent, all you have to do with those two, you just cross them out. Similarly here, cos same base, cross it out, 2 same base, cross it out. Be good. You will be left with negative sin theta plus sin theta, which gives you 0. That's it. Well, why did I have to do it this way? Because I can't rely on my memory, as I've said. My memory is very, very picky. So I rely more on understanding. Once I understand something, it's easy for me to do anything. I don't have to remember the method and stuff, as long as I understood what I was doing. It's because when I was writing paper 2, when I was in matric, paper 2 was my favorite. I enjoyed paper 2 more than paper 1. And I had already written paper 1. I knew that I had passed paper 1, but I couldn't allow my paper 1 mark to be higher than my paper 2 mark. So the day before paper 2, I decided not to sleep. I think I slept at around 4 a.m. And I woke up at 6 and then went to write. I think we were writing maths at around 9. And that was the biggest mistake. When I got to the exam venue, and obviously there's prayer and other things, they gave us the papers and everything else. And immediately when I opened my maths paper, everything went blank. I could not remember a thing. And with me, I had plans already that, I need to go to vet and to study BCom and become a chartered accountant. And I need a good math mark. I need a good English mark. My English was on point. My home language was on point. The problem was paper 2 math. So in the first 10 minutes, I could not remember anything. So I thought probably things will come back because this was my strongest. And 1 hour sitting there, I could still not remember anything. And that's when I was like, oh my word, I'm going to stay here in Boki for the rest of my life. I'm going to stay in a shack and it'll just be a cycle that doesn't stop. So my dreams are done. I'm done. And I started crying. And I remember one of the teachers that was invigilating just looked at me and there was nothing they can actually do. And because I could not remember anything, obviously I could not answer anything in paper 2. I could not answer anything. Okay. And that was because back then, I was rushing to finish because I didn't have a matric math teacher, and I had to teach myself everything. And I relied more on my memory. And when my memory failed me, it was over. It was over. And it failed me when I needed it the most, which was in math paper 2. And when I got, fortunately, I managed because obviously my paper one mark was way too high because I wrote nothing in paper two. The only thing that I wrote in paper two was geometry. And that is because Euclidean geometry was the only thing that you could do without memorizing. It's all about you looking at the angles that you've been given, and you just have to reason why that is true. And so that one for me was quite easy because I didn't need to remember the theorems and all of that. I just understood the theorems. I didn't memorize them. That is the only thing that I answered in paper two. So for me to get a mark that got me into VETS, you must know that I must have nailed paper one. And because of that, when I got to VETS, I came across trick again. Yep. And I had to change the way I studied. And when I got there, one thing I focused on was to make sure that I understand everything that I do and not memorize. And when it comes to Cartesian plane and reduction formulas, this is the only thing that I had to come up with. I had to understand, why do we have 90 plus? Why do we have the plus? What does that plus mean? And I realized it means moving anti-clockwise. And that's all. I can answer anything you put in there by just knowing that when I move from this angle, I'm adding is anti-clockwise. When I'm subtracting, it's clockwise. And that's it. That's it. And obviously, just have to know that all ratios are positive in the first quadrant. In the second quadrant, it's only sine. In the third quadrant, it's tan. In the fourth quadrant, it is cos. That's all. And yeah, I nailed math in my first year because of that. Because I focused more on understanding instead of memorizing things. All right, let us look at this one here. We are given that cos x is equals to p. I don't know why I wrote the end between given and cos. And they told us that whatever angle we have is between 0 degrees and 180 degrees. Now, note that whatever we have as cos x is positive. And cos can only be positive in two quadrants, which is the first quadrant and fourth quadrant. But here they limited us. They told us that we can only work between the first quadrant and the second quadrant. And between those two quadrants, cos is only positive in the first quadrant. And that's why I drew my right angled triangle in the first quadrant, where the angle is x. And I'm told that cos x is equals to p all over. So the fact that I don't have the denominator of p, you need to know that a denominator of p there will just be 1. All right. Now that tells me that adjacent to x, I've got p. The side adjacent to x will be p, and the side hypotenuse, which is opposite 90 degrees, will be 1. I'm missing the side opposite x. And for me to get that side, which is unknown, I had to use the theorem of Pythagoras. I end up having the unknown side as 1 minus p squared. All right. Now, if I want to calculate sine x or sin x, it'll just be opposite over hypotenuse, which is the square root of 1 minus p squared divided by 1. And that'll give me the square root of 1 minus p squared. That's it. And then for cos, the only thing that I know when it comes to cos is that cos is equals to cos squared minus sine squared. And that's the only thing I need to know. In my head, I can manipulate that. That's why I say focus on understanding than memorizing. And because I had seen in the previous question, I decided to use this one here. Where there's sin squared, I substituted that 1 minus square root of 1 minus p squared. The square root and the 2 cross each other out. Inside that bracket, I'll be left with 1 minus p squared. And when I multiply out by negative 2, this is what I'll end up having. And negative 2 plus 1 will give us negative 1. And I just put it at the back of that 2p squared. That's it. Oh my word. Now here we need to determine the general solution. And one thing I notice is that I have two different ratios on both sides. And fortunately, those ratios have a common angle, which is that x minus 30 degrees. If there was no common angle, we were going to change one of the ratios by introducing 90 in front of the angle that you have. But I didn't have to do that here. Once you have cos and sine, which are two different ratios, and they have a common angle, you can just divide both sides by cos. And that will give you 10 of that common angle, which is equals to 1. So why do I have 1 on the right hand side? It's because I said cos of x minus 30 divided by cos of x minus 30 is 1. Divide both sides by 2, you end up having 10 of x minus 30 is a half. And then you just find the inverse 10 of a half, and you introduce that plus 180 degrees times k, where k is an element of integers. That is because 10 only completes a full circle after every 180 degrees. Now find that angle, which will give you 26,6. Please note that the instruction in paper 2, just why guys, make sure you read instructions carefully. It specifies that all the answers must be rounded off to 1 decimal place unless you are told otherwise. Here, you probably got 26,56 or 57. But because they said round it off to 1 decimal, that's why I've got 26,6. Now, all I did was just to transpose 30, and I'm left with x on the left-hand side. When I transpose 30, it'll be plus. The reason why I highlighted those two in red is for you to see that those are like terms. And that 180 is not a like term because that 180 has a variable k multiplied with it. So I cannot add that 180. So I only add 26,6 degrees with 30, which will give me 56,6 degrees. And that's it. Done. All right. Moving right along. Oh yeah. This was a little bit of a challenge for me because I'm used to doing it manually. And normally you find a period. The period is simply the coefficient of the angle. You take 360, you divide it by the coefficient of the angle. Like for instance, for 2 sin x, the coefficient of the angle x is 1. So your period will be 360. Then you will take that 360 divided by 4 to figure out how sin behaves in each quadrant. That's why we're dividing it by 4. And when you take 360 divided by 4, that gives you the steps. Okay. Back then we used to say it's it tells you how your graph will be moving. So what you need to add from your original angle. And how do you get to the angle that you need to start with? You will take whatever is in front of the ratio. For instance, for x, what's in front of x, the angle for sin there is x. You will take that x equated to 0 and then solve for x, where you will have x is equals to 0. That's where you will start your your Cartesian plane. That's the angle you will start with. So if I was to do the Cartesian plane for 0, my starting point will be at angle 0. And then to figure out what my next x coordinate will be, I just add 90. How did I get that 90? It's what I did when I took the period and I divided it by 4. So 0 plus 90 will give me 90, and 90 plus 90 will give me 180, and 180 plus 90 will give me 270. 270 plus 90 will give me 360. We could. And that's how I will find my x coordinate. The amplitude obviously is whatever the coefficient of the ratio is. That is us doing manually. But now, because I promised that I'm not going to look at any textbook here, I'm just going to use my understanding from what I understand. I know you guys are using a calculator, so it took me like 30 minutes to figure it out, how to work it out using a calculator. So I went here and I went to table. For f of x, I only dealt with 1. For f of x, I wrote 2, and then I had sine, alpha, then I had x, close bracket, oh my word, oh, close bracket, and then press the equal sign. G of x, for now, I won't do them at the same time, I'll do them separately. The starting point, as I've said, you will take whatever the angle is there and equate it to 0. So I took x and equated to 0. That means I'm starting from 0. But obviously, according to the Cartesian plane, according to the limit that you were given there, either way, you have to start at 0. If it said we must start at negative 180, I was still going to start at 0. And when I move to the negative part, you'll just minus 90 until you get to 180. When you move clockwise, you just, when you move anti-clockwise, obviously this is just in positive ways. When you move to the right, you just add 90, add 90, add 90. When you move to the left, you will minus 90, minus 90. Okay, here my starting point will be at 0, and I'll end at 360, obviously. My steps will be that I told you to find the period. You just have to take 360 and divide it by the coefficient of the angle. The coefficient of x there is 1. Okay, so that will simply give you your period, and then you take that period, you divide it by 4. So 360 divided by 1 will give you 360, and then 360 divided by 4 will give you 90. So my steps will be 90. Okay, this is because I don't want to go there. No, let me not go there. Okay, I don't want to tell you why I said it's because. Now, that's what I'm going to get. So for my first coordinate, I have 0 and 0. The second one, I'll have x is 90, y will be 2. The third one, I'll have x is 180, y is 0. The fourth one, I'll have 270. Okay, what's going on there? I'll have 270. Let me just check. It'll be 270 as x, and y will be negative 2. And then I'll have 360, and y will be 0. Okay, and plot those coordinates. So these are the coordinates when I plot them. And then just draw your graph by connecting those dots, and this is what you will get. This will be the graph of sin of x, and that's it. Obviously, you'll just write the coordinates. I'll write the coordinates at the end. Okay, now let's move to cos now. How do we do cos? So first of all, I'm going to start with the starting point. I'll take the angle, which is x plus 30 degrees equated to 0, right? And then solve for x. So you'll have x plus 30 degrees is equals to 0. When you solve for x, you'll end up having x is equals to negative 30 degrees. So that's where you will start 80, right? That's the angle you will start with, negative 30. But the problem is that here, we can't draw the graph to the negatives. We can only draw the graphs to the positive, starting from 0. Question is, what do we do? So I know that I will start at negative 30, and then I'll just find my period. And for me to find the period, I'll just take the coefficient of, in this case, you won't know what it is. I don't know if you guys know what it is, but the coefficient of the angle there is just 1. So when you take 360 divided by 1, it'll just give you 360. And then you will take 360 divided by 4. So it means that it'll complete the circle after every 90 degrees. Okay. Now, once I get that, I'll just keep on adding from the starting point. So obviously, I'll start at negative 30. From negative 30, when you add 90, you will get 60. From 60, when you add 90, you will get 150. From 150, when you add 90, you will get 240. From 240, when you add 90, you will get 330. And this is me. This is how I will do it. Let me see. I managed to figure it out with your calculator. I hope I'll get it right. Okay, so what I did is that I went to 3 again. My table will be 2, and then I'll have pause and open bracket, then have alpha x plus 30, then close the bracket and equate. My starting point, obviously I don't have G here. My starting point will be, I said it's negative 30, all right? And I'll end at 360. My steps will be 90 and voila. Because I don't have negative 30, obviously we're not required to draw to the negatives here. I'll start at 1. We'll come back to when the angle is 0, but I'll start with 60. So let me see what the coordinates of angle 60 will be. The coordinates of angle 60 will be 0, okay? The coordinates of 150, the coordinates of 150 will be negative 2. As I'm saying, you need to, well, actually, why does it have negative 2 there? What did I enter incorrectly here? Can I just check quickly? Oh, I entered 2 there and there's no 2. Sorry for that. Sorry for that. Okay. Okay. Nothing changed. So this is what I'll have. For negative 30, I'll have 1. For 60, I'll have 0. Keep on writing those coordinates, okay? Keep on writing those coordinates. So when you write the coordinates for 60, you will write 0 there. It'll be there. And for 150, we have negative 1, so it'll be there. And then for, what's the next one? It'll be 240. And for 240, we will have 0. And for 330, we will have 1, but then we have to stop at 360. So we have to figure out what cos of 360 will be, and we'll get to it shortly. Okay. But I'm going to start with the angles first, okay? And I will explain how I got to cos. Let me just start with the starting one. So I'll just have to move out of this. Okay. Okay, how do I move out? So I'll go to mode. No, I'll go to mode and just, yeah, that's how I'll move out. I'll punch in there cos my starting point will be 0 plus 30. So where there's x, I'll just substitute 0 and then it gives me this. And when I write it as a decimal, it'll give me, so my coordinates of 0 will be 0 and 0, 0,87. And here they said to one decimal place. So it'll be 0 and 0,8. But I don't think they'll penalize you for writing it as 0,87. Okay. Unless I'm missing something here. So this is what I will have, 0 and 0,87. Okay. And the next coordinate will be, I'll just plot my points. Okay. So I will plot my points, and this is what I will get when I plot my points. I started with 0, obviously, and then I went to 60, then 150, it was 150 and -1. At 240, it was 240 and 0. At 330, it was 330 and 1. And at 360, we haven't calculated that one. Let's see how much that will give us. So you still put in the ratio as it is, which is cos, where there is x, you substitute 360, and then you add the 30 equal sign. That's what you will get. You'll still get 0 and 0,87. So it'll be around there, over there, around there. Okay. I hope this did not confuse people. Okay, it'll be around there. Yeah, it'll be around here. Let me just put it there. So when I draw my graph, make sure, guys, it's KV, okay? So when you connect the points, you will connect them in this way. And that's what you will have, and that's your graph. Done. Make sure you have written all your coordinates, okay? Now, for B, it says, show that the graph of G can be written as that. Okay, the graph of G can be written as that. All I did was just to write the graph of G as it was given to us. And I just expanded it. And when I expanded it, this is what I got using compound angles. And cos of 30 gave me square root of 2 over 2, square root of 3 over 2. And sine of 30 gave me 1 over 2. And all I did was just to take half as a common factor, and voila, that's what I got. And for C, they say indicate clearly on your graph the values of x, highlight x, for which 4 sine or sin x is equals to square root of 3 cos x minus sin x. I realized that what I have on the right-hand side, it's exactly what I have in P, except that there's no 2. And I realized that this 2 here, all they did was just to multiply by this side. And when I divide both sides by 2, it gives me this. And immediately it gives me this. It tells me that on the right-hand side, that is the graph of F, and on the left-hand side, that is the graph of G. And they just want a point where these two graphs are the same, where they're equal, which is just the point of intersection. And they intersect at this point here. But they're not looking for the point of intersection. They're just looking for the x value at that point of intersection. And you just needed to show it. And that's all you needed to do. Done. Finito. All right. Oh, it looks like we're done, because the next question is about this. So you can try it out and calculate this and that. check out the next video for solutions to that. I hope you're enjoying and I hope you're having fun and you're finding math easy. If you have any questions, feel free to send me an email or just comment with your question. All I can say for now is Kgotso. Have a great evening. Thank you for watching. Don't forget to like and subscribe and let your friends know that there is a cool math what? I don't know. Just tell them that there's a cool place where you can just get to understand math, right? Cool channel. I don't want to say cool channel. But anyway, thank you for watching. Like and subscribe and hit that notification button and let everybody know. Okay? Kgotso.